What we're going to talk about today is, as part of how to choose a tool, we're going to talk about what's the purpose of static analysis. So that if we don't know what we're using it for, it's hard to pick the right tool. We'll look at what are the common capabilities. I do want to briefly poke at some of the intangibles, because between the intangibles and how you pick the tool, you can really make or break a static analysis initiative. And one other thing, when you signed up for this webinar, we had some questions in the registration form. And I looked over those, and it turned out that they all broke down to about 5 different categories. So one is about how to measure ROI, how to demonstrate ROI, how to make the case to my manager, et cetera. We're going to show that in a few minutes. Noise and false positives, some issues around security, issues around open source, and then specifically static analysis and technical debt. So we're going to cover all those in detail, and I appreciate you putting your questions there. One little hint here, you see that little icon with that little dude at the top right poking out? Every time you see that, we're covering one of these questions. So you'll know as we go through, as we're hitting your things. So Erica, if you'd start the first poll, I just want to get a feel for where people are at so that I can kind of control what we're going to do. Pick one of these. Are you just getting started with static? You don't do static. You do it, occasionally, one-off. Maybe you do it once every month, or maybe you do it when you feel like it, or you get worried about a particular thing. Do you do it regularly? Is it like part of your CI/CD? Maybe it's even a gate where people can't do it. So put that in there, and we'll just get a feel for where people are at, and we know how many people are just starting and how many people aren't. Erica, do we have enough to close it and get some numbers? All right, wow, it's an even mix, right? We see that about a third of you are just getting started, a third of you use it occasionally, 20%, about 20% don't do it. So it's a pretty interesting mix. Okay, so let's dive in. What can static analysis do? In other words, what's the purpose of it? So there's a bunch of different things static actually does. And a lot of people think of static just in the context of security, but it's much broader. It can identify defective code, like things that would normally happen at runtime, and that's that flow analysis, big security tainted data thing. It can also flag code that's prone to defects, things that aren't necessarily bugs, but we know that under certain conditions they'll fail. And so if you want to make the code really, really safe, it's good to do them. Static analysis can suggest defensive programming practices, like always initialize variables when you declare them so that you never have uninitialized memory. And you can do some really cool, like application-specific things. Maybe portability is an issue for you, or maybe you're running on a small device, and so you need to be extra careful of memory consumption. You can put all these things into static analysis checkers. And you can also look for things like code that's a pain to maintain, code that's hard to read, code that's complicated, code that will be difficult for another developer to work on. And finally, static analysis actually trains developers to code better. And I used to think this was crazy, but I experienced it myself on a particular static analysis checker about closing resources in a finally block when you have a try-catch block. And this little message would pop up and say, oh yeah, don't forget to close your database resources in a finally block in case something fails. And over, this thing would nag me, and I'd do it, and I'd do it. And eventually I just stopped getting the message, because I started writing the code that way. It literally changes your behavior over time, which is really cool. So as you're picking static analysis, you need to ask yourself, why am I using static analysis? Am I trying to meet a specific compliance issue? Maybe it's FDA or automotive, MISRA. Maybe I've got PCI compliance because of credit cards. Maybe it's security issues. It's important to understand why you're doing it, and ask yourself, is my development process stable, repeatable? Because if it's not, you need to do that first. If you've done static before and you had problems with it, you need to look at, why did it fail? What happened? How can we make sure that's not going to happen to us again? The basic process I look at is here on the right. We look at the issues that we're having in the real world. Is it security issues, performance issues, field bugs, et cetera? Look at the root cause. Obviously, you want to fix it, but we look at, is there a static analysis like a flow analysis checker that would find this earlier to let me shift left? And where possible, is there an even stricter static analysis checker that would prevent this? I call this shift lefter because we've already shifted left, but like even earlier, prevent it in the first place. So the other thing to think about is, is this going to be a corporate-wide initiative? Is every group going to be able to do their own thing? And legacy code is a huge issue. And this is one of the things that really zaps people. You need to make sure that you understand what your policy is around legacy code. In other words, will new code and legacy code have to comply with the same set of checkers, or will new code be held to a stricter standard and legacy code is maybe only if there's a bug reported issue? So it's an important aspect. Some basic best practices. First, figure out a useful set of rules, right? Like in checkers, what do you want to run? Run it. Make sure you have a policy so that people understand, fix them. Repeat until you have an acceptable number of violations and look at, is this a good configuration? Can I share it with other people? Typically, I like to set it up so that the desktop IDE, where the developer actually works, is doing finding and fixing. They run it before they check in, for example, before they promote code. And I use the CI or the build for assurance. In other words, it should make sure that there aren't static analysis violations. There are some times where you need to run it in the CI because of how your setup is, and that's okay. But ideally, if people are finding things as they're typing them, it's right in their mind, they can respond faster, and it makes for a better thing. Now, when you're looking at this determining useful set of static analysis checkers, you ask yourself, what am I going to pick? And the answer is pick things that are happening in the field that you've had to fix in the past. Again, did you have a performance problem? Did you have an uninitialized memory problem? Things you worry will happen, like security. Things happening in the news, like security. Standards that you have to comply with, like PCI for credit cards. And pick checkers that have an exact correlation to the problem. So that when someone says, why do I have to do this? You can say, well, we have this requirement. Or remember that bug we had in the last release? This is going to get rid of those things. So here's our first question that had come up again several times with different words. But how do I know that it's working? How do I show my boss it's working? How do I show my boss the value? How do I make the case that I need the money for the tool? Now, one of the tricks in the software industry is we don't have standard metrics and measurements. So this is a problem because, like Drucker says, if you can't measure it, you can't manage it because you don't know, is it getting better or worse? So we need to look at, what can I measure with static analysis? And one of the common things that people run into is they'll say, well, let me measure the number of violations that static analysis finds. This is a great early metric. But without some context, like which ones led to critical bugs, which ones did I ignore, which ones were in critical pieces of the code, which ones were, a medium severity, it's hard to really assess. And the truth is that as a product matures, you stop making the same problems and the tool starts finding less and less violations. Does this mean the tool had less value? Nope. It means that it's doing its job, it's changed developers' behavior, it's preventing problems. And so better measures long-term are often things like, are we meeting our schedule? How many bugs are we finding in QA? How many bugs are we finding in the field? And if your static analysis is directly correlated to the problems you're having in the field and to the things that you find in QA, then those numbers should be going down. But be careful about misleading measures, again, because, like I said, if you just measure the number of things static analysis finds without context, that number must go down over time, because if you're actually fixing them, then there's less of them in the code. And if you keep fixing them, you'll stop doing them in the first place. The way to know if you got the right number is ask yourself, as I'm doing this, does the number change? In other words, if I say, hey, last release, we had 10 field issues. This release, we still had 10. Well, maybe it's not the right number, or maybe it's not the right config. And that's really what's important to understand. Look at the number and see if it's moving. If it's not moving, either you're measuring the wrong thing, or you're doing the wrong thing. And I've seen this time and time again. I had one organization I went to, they turned on static analysis. They were doing it religiously, as they claimed. I don't know what that really means, but they claimed they were following it and fixing it. And nothing was changing in the metric they had. And I asked them, well, did you turn on checkers related to your actual problem, which was blue screens in a Windows app? They said, no, we just turned them all on. So, well, okay, so we don't know whether there's a correlation between the number and what we're doing. Another thing is to make sure whatever measurements you're doing, they're consistent. They need to be automated, whether, again, it's from your bug tracking system. It can't be gut feeling. It can't be a manual process where we ask people to add up their numbers, or we just won't know if we're getting better. So Erica, if you could throw up the second poll as we go forward, I want to know how much time to spend on each of these topics. I'd like to know what you think your biggest challenge is. We made this a one choice poll, so you just pick your biggest one. Don't pick everything that bothers you. But is it literally finding the right tool? Maybe you've had multiple tools and you're not sure. Maybe you've got different teams that have had different tools and you're asking yourself, do we push them all to one? Do we keep multiple? Is it getting the right configuration, understanding the right checkers? Is it noise and false positives? I suspect a bunch of you are going to do that. I probably shouldn't say that. I'm trying not to skew the results, but that's a common one. Is it determining and demonstrating value, or is it something completely different? And if you're in that other group, like, feel free to put what the other is later in the chat box or in the QA. Happy to know, happy to maybe talk about it. Erica, if you could click that and let's see what we got. Awesome. So again, a relatively even spread, but the two big ones were finding the right tool and determining and demonstrating value. So that's pretty interesting and not shocking. Those are actually complicated because people most often choose static analysis tool because it's free, because they used it in the past, because somebody in another group liked it and it worked well for them, which doesn't mean it will work for you. So let's dive in. One thing I've noticed is that when you start to compare things like static analysis tools, from a high level, they all look just the same. And so I've created a chart here to talk about what are some of the core features and capabilities that we expect modern, mature static analysis tools to have. And this is important, right? Because there are some little tools, some old tools, some, not well-used tools, kind of obscure tools. They don't have anywhere near this set of features, but these are things that we expect and see in the field with normal things. Now, this is an enormous list. We're going to send you the slides afterward. We've got a white paper that's going to go into detail on every one of these items. But I just wanted to cover a few of the most important ones today because we could literally spend an hour on each of these topics. So let's talk about the configuration issues. A few most important things to look for. Make sure there's centralized configuration that has permissions control. You don't want to end up with the scenario where you have 100 or 1,000 different people using static analysis and you decide to update the configuration and you've got to go to 1,000 machines and update it. The configuration needs to live in one place so that everybody gets the right config every time without thinking about it. And it needs to have permissions potentially, because in some organizations, it's okay for anybody to do what they want. In a compliance organization like automotive or financial, I might need to be sure that only the right people can change that configuration. You need to have flexible options. I see a lot of people fail with that noise issue because the checkers given to them by the tool don't give them the choice which checkers to run or how to change the severity level for the checkers. So those are really important. If you have big code, it needs to work with big projects as well as small. I don't know what big means. It's a different number for everybody. I have worked with projects that are in excess of 25 million lines of code, not in the company, but in a single code base. So however big your code is, you need to make sure that the tool can scan that project successfully and output results inside a necessary time frame for you. Is it a once a week? Then it could run maybe overnight or in a full weekend. Is it overnight? It needs to run in less than 12 hours, probably less than 8. Is it CI/CD you need to run in a few minutes? So important for you depending on what you need to do. And licensing that fits your needs. Boy, like again, like sometimes people really want to use static analysis and then they're inhibited because the licensing charges them per execution or per line of code they run through it. So they only run part of the lines of code or things like that. Or maybe they're trying to do a cloud deployment and the license won't work in the cloud. It's important that you look at how will this thing work, where I'm going to deploy it, and legacy code. Again, if the tool doesn't have configuration options for fixing code based on component age, checker, other legacy type policies, severity, you're going to have a really hard time to get lots and lots of noise. So legacy code is just one of the big hurdles. And honestly, it's one of those hurdles that's actually very, very easy to approach if you have the right tool. If you have the wrong tool, it's insurmountable. So let's talk about noise. You'll notice I didn't say false positives. It's noise that's a problem. It's incorrect messages. It's things that aren't helpful. It's things that are irrelevant, right? Like if I get a performance issue and all I'm worried about is security, anything I don't want to hear. Now that's a problem potentially, but let's live with it, because anything I don't want to hear, anything I'm not going to work on right now, just isn't helpful, and that's what really kills people. This noise leads people to believe that static analysis is a pain, and you'll notice that this is one of our key questions from people when they registered. So this is really important. False positives have varying definitions. Literally, a false positive means that the tool said something and that the finding was literally wrong. Now, different kinds of checkers have greater or smaller probability of being wrong, but in general, people apply false positives in an extremely broad thing to say, well, I don't like this, this isn't important to me, I don't see why it's a problem, something somewhere else will fix that. That's not an issue for me today, I'll fix it later. Those are all real noise issues. They're actually not real false positive issues. And it's only important to make the distinction, not because I'm trying to make a tool sound better, but because a tool being wrong means a discussion with the vendor to fix it. A tool running a checker on legacy code is a configuration issue. A checker that you simply don't like is a configuration issue. Something that you don't see why it's a problem, that's first a training issue and then maybe a configuration issue. I would hesitate to just turn things off if I don't see why it's a problem. I would want to look at the docs, and then if I see the rationale and go, I don't care about that, then turn it off. But if I go, oh wait, maybe that is important. Quite frequently, you should find that things that you don't understand why they're important are important, because most static analysis tools that are mature and have been around for 2 or 3 decades really represent hundreds, if not thousands of years of software development knowledge. It's like having a senior programmer look over your shoulder and say, oh man, I know that looks like it's going to work, but it's really a bad idea. So it's important to understand them. In this context, does it apply here and now? And then how do I deal with the noise, with the false positives? There are different ways to document them. The most common ways are, there's an inline method that lets you do it in the code. I know some people get horrified by this. I don't want to change my code for static analysis. Well, if something's failing, you're going to change your code for static analysis. So maybe that's an odd decision. I like in-code suppressions because they're persistent and auditable. If I'm in a compliance environment, I can literally prove that someone looked at it and said it was okay, because my source control system has who did it and when, and probably a message about why. And it never gets out of sync. It never has problem with cut and paste. It never has problem with branches, etc. So inline is actually probably the most effective way. But some people have real reasons why they can't do it. Legacy code, for example, is one. So it's important that the tool also has a way to do suppressions outside of the code, but it needs to be more than just the desktop. It needs to be centralized and shared so that if I suppress something, Erica doesn't get the same message. If these suppressions aren't persistent, then we have a real problem and we create more noise. If the suppressions only persist through one build or through one branch, then we have a problem and the tool really isn't effective. Now, you have to remember that with flow analysis type of checkers, false positives are inevitable. The trade-off is, look, they find real bugs, but 15% of the time they're going to be wrong. Now, if you think that flow analysis or static analysis in general is a much higher role of false positives, that's 15% is about the amount of time that the tools are wrong. The rest are got the wrong rule, applied it to the wrong code, wrong severity that isn't important today, don't understand it, don't like it, etc. That rest of that falls into those buckets. So they're really configuration issues, which means they can go away. So to reduce this noise, make sure you get the right configuration with the right checkers, that you apply it to the right code. Maybe it's a cutoff date. Maybe you only apply it to code. If it's a new initiative, I would say apply it to code as of September 1st and start there. And when you come into compliance and you've got a small number of things, then move that date backward. Or maybe you say that code checkers and code before September 1st gets only critical checkers and only, for stuff that was only 30 of the rules, right? 30 of the checkers. So there's a lot of different ways to get it. Use suppressions, they said, and use severities. Like good tools let you set severities at critical, high, medium, low, informational. I think about the Unix POSIX style. Like critical to me means, oh man, if I knew that, I would fix it and I would issue a patch. High means I for sure want to fix it soon. Medium means, hey, I should probably fix this, before I do a release, but I can look at it, I can check. And honestly, in static analysis, I don't know why you're running a checker for anything past that, because the truth is you're never actually going to fix it. So there you go. Let's talk about integration, because it needs to work in your world with your things. I'm a firm believer that static analysis tools need to live in the IDE, not only in the IDE, but the truth is developers work in the IDE. And if they have to go to a different system to find problems and then come back to the IDE, find the right file, find the right line of code, try to understand why that matters, go back to the other tool, look up the docs, it's just not very effective and it slows people down. You need to be able to go into an IDE, get a list of things that are wrong, just like you do with compile time errors, and be able to do right click, take me to that line of code, right click, take me to the docs, right click, do a quick fix, like go to source control, check it out, check it in, things like that. So it's really, really important. Now, that being said, I believe in a trust but verify model. So I ask developers to run static, but I check it in the build system, in the CI/CD. Maybe you're doing cloud. Maybe you're doing on-demand dynamic execution in containers. Maybe you're going through AWS or Azure. Your static analysis needs to work in all those places. You do need a web UI because some people aren't working on code and they need to be able to look at violations and drill down and see, oh, what is this? What kind of a problem is it? Where does it lead? Can I see the code? Can I see what branch it came in? So all those things can be useful to management, to architects, to team leads that may not have the project on their desktop. Source control, super critical. There's lots of like simple lightweight tools that don't connect to source control, but without that, I can't really manage these things properly. I don't know who did it. I don't know who's responsible. I don't know when it appeared. I don't know if it's in other branches and things like that. So a good static analysis tool integrates with your source control system and your bug tracking. You want to be able, when necessary, to file things as issues, and you want to be able to correlate various checkers to issues so that later when you're doing your postmortem, you can say, oh my gosh, we fixed that static analysis violation and we had that field problem and it was the same code. So I'm going to turn that checker on everywhere. I'm going to make that more critical for me. So it's really important. One thing I would caution you against, there's a strong desire sometimes to say, hey, I'm going to use bug tracking as a blocker. I'm going to automatically file all static analysis violations as bugs. Don't do that. Static analysis falls into different categories. Some of them are probable bugs, but again, they have some level of false positives. Some of them are things that you should inspect, some are things you should peer review, some are smells. Like, I don't know if this is a bug or not, but it looks funny to me. So you might want to fix it, you might not want to fix it. These things just don't belong in a bug tracking system. So it, if you're going to do that, do it very carefully, only for the most critical checkers and for the ones that you know you always want to fix. Otherwise, maybe leave that to other parts of your system. Requirements management, it's great to know how do these things associate with requirements. Do I have a requirement for security and I have a static analysis checker for security? Then it's great when I do an audit to know what I did. Yes, I'm OWASP compliant. I ran these particular static analysis checkers against this code because of that requirement. And then in your world, there's a whole bunch of other things that you probably need to work with, and everybody's is a little bit different. They're all snowflakes and they all look alike from far away, and up close they all look different. So it's important that static analysis tools have APIs so that you can execute them, so that you can get data out of them, so that you can build them into a pipeline, plugins for IDEs, plugins for Jenkins and things like that. CLI, because whether or not you think you need it, you've probably got some crazy system somewhere that the only way to integrate and automate is a CLI. So for sure, you want to have a CLI in addition to APIs and plugins. It's still the most common universal. If you haven't done DevOps yet, you might not have bumped this. The second you bring those ops guys in, they're going to want a CLI. That's just part of the real world. I want to talk about the IDE because the IDE is super important. I've said that it needs to be there, and I've shown you that, for example, your results need to come as a uniform view, just like other tools in the IDE. I want to go beyond that because, again, there's this age-old problem of, do I run static analysis in the IDE or do I run it in the build system, the CI/CD system? And that question should be a process question. But what I don't want to end up with is, if I run it on the desktop, I get one answer, and if I run it in CI, I get a different answer. That's bad. And I don't want to end up with, if I run it on the desktop, I get lots of useful information. And if I run it in CI/CD, I don't get the information I need, and it takes longer to understand, what is this? Why do I care? Where's the documentation? Where's some code samples? I have literally had a client that I got a tech support request. Somebody said, well, I don't understand. Where's the documentation for this rule? What's the severity? Where's the stack trace? And it turned out that their ops person had rolled up all the static analysis violations into a spreadsheet and just mailed them to everybody. And so they lost all that integration. So it's not just the IDE is important, it's that a really good IDE can import the results from a CI as if it was run locally, and it would show up here in this little pane, just as if I had executed it locally, letting me click on a particular violation, go to that line of code, see the stack trace, check it in, check it out, do what I want to do with it, all inside the IDE, regardless of where my results came from. Yet most tools don't do this, but this is super critical to effective running if you're trying to do continuous. If you've got a CI/CD pipeline, you've got to be able to make sure that the results go back into the IDE. I can't stress how important that is. Let's talk about ease of use. We want to make sure we can get a straight line from A to B. Static analysis should make people's life easier, not more difficult. Ideally, static analysis makes your life easier, not just, it's telling you to do something that you weren't going to do, but that was a thing that you should be doing. So what are the key things that make a tool easy? Well, docs for every checker. Static analysis needs to have detailed docs for every single checker they support. It needs to say why this thing matters, especially in security. Buffer overflow is a security issue. Why is that? When I look at things like Heartbleed, checking parameters for valid ranges is a security issue, but people might not know why. Why does this matter? And you need right and wrong code examples. What does this look like in the real world? And how on earth would I fix it without breaking the code? So your docs need to really have this and have links through to the appropriate standards. If it's OWASP, it should take you to OWASP. If it's CW, it should take you there. If it's MISRA, it should take you there. And even where possible, maybe you need some online training. Maybe you've looked at resource leaks and you're getting static analysis violations, and you just don't get from the code sample and your code how to make it work. It's great to have links to online training, maybe quick videos that just say, here's an approach, or maybe an in-depth course that teaches you all about how to do something. The results need to be where the developers live. We just talked about that. And we need built-in support for the standards. And this is super critical because a lot of tools have something that they'll call like a map. So they'll say, hey, I support OWASP. There's a thing called OWASP Top 10, and I have maybe even a config for it. But then when I look at the results, they say like checker A, checker B, checker C. I don't know which OWASP they go to. And the reason these vendors do this is that they don't actually have checkers for every item in the standard. So they do this little funny thing, they don't map it, and you're left with not knowing how to configure, not knowing when you're fixing what you're working on, and not knowing in reporting an audit if you've done everything you need to do. So when I say a built-in standard, I mean the standard needs to be there. You don't have to build the config. I mean that the standard is labeled. If you're working against MISRA, that the checker is MISRA 1A, MISRA 1B, etc. That you don't need a map. I call this mapless. I call it native to the standard. When I'm doing CWE or MISRA or PCI, that it looks like I'm doing PCI and not some funny abstract overflow error, and I don't know what item in the standard it's part of. And where possible, quick fixes. Now, I'll give you a caution. Quick fix only works on the most trivial violations, but if you're trying to enforce a particular kind of coding standard, it's a great way to quickly come in compliance and again, reduce that noise. So it can be important. Let's talk about reporting and analytics. So it's important that we can deal with data. The most important things are that your tool can handle data from other tools, that it can aggregate with the other tools. If I have, 3 static analysis tools and 2 are from one vendor and a third from another vendor, I still want the results in one place. And it might be that I want to gather all the data together and the tool has a reporting UI or a reporting database, and it's now the center of my universe. Or it might be that it did something and I need to pass it off to a management system that wants statistics. So I need both input APIs as well as output APIs, as well as built-in extensible programmatic ways, not just to have plugins available for third-party tools, but a way for me to support a tool that maybe no one else has seen, and I still need it to be part of my workflow. So all of these are important from an integration perspective. I need visualization things. So I need, if you look on the left here, this is a standard kind of a dashboard, lots of widgets. If you watch one of our demos, you'll see that each one can be resized, can be changed. You can change the filters. You can repeat them for multiple projects. You can drag and drop them. You want all those things. You want a rich set of widgets available to you. You want a rich set of filters so that I can filter by projects, by severity, by standards, by business unit, by components, all the different ways to slice and dice. I want to see trends and history. Am I getting worse? Am I getting better? Can I look at it by severity? Can I look at it by impact? We're going to talk about that in a moment. Can I visualize what my actual risk is? Those of you who are deeply steeped in security will recognize this matrix at the top right. Those who haven't done security deeply may not have thought about static in concept of risk, and you just think of them all as findings, and you need to decide whether or not they're important. They actually have some intrinsic value that you can use. And a really good reporting and analytics center lets you connect to the analytics. It lets you start to understand, and change. Here's what's important to me. I want to take, anything that needs to be reviewed and is in low severity and just mark it as ignore this. I want to take anything that's critical and mark it like to be fixed right away and notify the individual developer. So having workflows, having the ability to create your own analytics and plug them into the dashboard with your own formulas. Maybe they're attaching to your spreadsheet. Maybe you have put a risk spreadsheet with a little table for all of the packages in your Java applications so that you inherently say that things in this package are super important and things in this other package don't matter. So there's just lots of nifty things that you want to have there. Audit ready reports. You want to be able, it's great. I love the web thing. Day-to-day management is the web thing. But if you have to send reports uphill, the problem with web reports is the web is always different. It's hard to make sure people see what they want. And sending it an email, maybe somebody's on a plane, they go to click it, it's not there. If you're in compliance world, the last thing I want is an auditor poking around in my system. So it's critical to make sure that you can download reports. Now, I know every browser can somehow print to PDF, and how well that works is highly dependent on the browser, the system, the page, the plugins available, etc. It's too much. You want like simple clicks that give you everything you can so that when you do have to do reporting, it's not so much an explicit exercise, but an implicit exercise. It's organic. I need to be able to see all of those things. Do I have a report that gives me my overview? I want that compliance nirvana that shows me what were the checkers that I used? How did they apply to the standard, right? And so if you look at that weakness detection plan in the bottom center, it shows you a requirement for OWASP A1, tells you what it is, shows you various risk scores for it, and then shows you all of the checkers that were used for it. And so if you look at the top right, you see which checkers were done and which ones are in compliance. If you look at the bottom left, I can see when I executed static analysis, what the results were, and deviations, in other words, suppressions. When did I choose not to fix things? They're all there in a PDF. All of this one click. That's the kind of thing that you want to look for, is that you can quickly get individual reports, but also if there's a bulk set of reports you want to get, can you get them without having to resort to record and playback and other RPA type of activities? Let's talk about standards and compliance. I view standards as a more strict form of static analysis because it implies that there's something behind there that you have to do. Now, there are so many coding standards out there, and some of them are specific to individual things. There's an F-35 called Joint Strike Fighter coding standard that's obviously required for that, but also probably useful for other planes, and truthfully, probably useful for any kind of a vehicle. There's CWE, which is for security. There's UL 2900, which is security for embedded devices. So there's lots of different things out there. And it's important that your tool implements the standards that you need in your world. If you're not using Joint Strike Fighter, then you don't care. But if you're doing PCI or HIPAA, then you really do care about those. The relationship between coding standards and static analysis is that static analysis is the mechanism to enforce a coding standard. In other industries, like electrical engineering, we have standards that say, if I'm going to have a certain load of electricity across a specific wire, here's how big the wire needs to be. Here's what the composition of the wire needs to be. Here's what kind of a coating I need to put on the wire. Does it have to be insulated? Can it be uninsulated? Does it need to be big? Does it need to be small? Does it need to be copper? Those are standards. We tend to think of coding standards as somebody annoying and nitpicking me, but they're actually meant to perform the same purpose. So if we look at like uninitialized memory problem, well, a runtime tool will find it if your test suite is thorough, if you have 100% coverage. Flow analysis, static analysis might find it depending on the complexity of the problem and the richness of how the tool's working and the time used to send to it. But you might have a pattern that says, again, whenever you declare a variable, you must initialize the variable so that there's nowhere in the code where there's even a possibility. Now, I'm not going to turn off the checkers that look for uninitialized memory, but they're never going to fire. They're never going to find anything. So that's the beauty of a standard. Some standards are designed to detect things early, shift left, as I said, because we're finding them now on the desktop before we get to QA. But some standards are designed to prevent. These ones people almost always call false positives if they didn't want it. And the truth is that they're never false positives. These kind of checkers are super easy to write. So it's, again, a configuration issue. Just one more quick example. You're familiar with the Leaning Tower of Pisa, right? It's not supposed to be leaning. It's supposed to be straight up and down. Very problematic to fix. Turns out the Washington Monument, when it was initially designed and they were starting to dig, was going to have the same problem. This was hundreds of years after Pisa, and they knew about Pisa, and they said, oh, let's not have the Leaning Tower of Washington. So they moved it. If you look at this as a Google Earth view, you can see at the top, the White House, at the bottom, the Jefferson Memorial, the left, the Lincoln, and the right, the Capitol. Right in the middle is where the Washington Monument was supposed to go. And you can see in that little red tag there, that little flag, that it didn't end up there because the ground there would not support a tower like that, and ultimately it would lean. So, you know, a detection rule would say, when you start putting the tower up, we're going to stick a laser on it or a level on the side, and we're going to say, is it straight? Is it straight? Is it straight? And once a year, we're going to monitor, is it straight? Okay, well, the prevention thing says, let's put this on bedrock with the right kind of infrastructure, rebar, concrete, etc., so that it doesn't ever lean. Because trying to correct a problem like that is a nightmare. By the way, you want to Google something funny after this webinar, like they're actually fixing the Tower of Pisa. It's something crazy like what you see here. This is way more expensive than digging a new hole, way more complicated. So prevention where possible is the right answer. Another thing from a standards and compliance issue, there might be metrics that you care about. Maybe you're doing cyclomatic complexity because you're doing automotive functional safety and you have to prove that you have a specific number. Maybe you're just trying to understand what's going on in your code. So these are all different examples of different metrics. I don't want to go into each one today, but your static analysis tool is the right thing to measure your metrics. It is a static analysis activity, and a good tool will not only measure all of these metrics, but generally will let you apply them as thresholds. So instead of just saying, well, your lines of code is on average 5,000 per file, you might say that anything over 5,000 is a high probability error, and anything over 50,000 is a critical issue, because honestly, that's a crazy piece of code. So they should all have thresholds where they're okay or not okay, so that if you're going to care about metrics, you can apply them as gates and part of a pipeline. And again, that's where we're all headed. So one of the questions asked was technical debt. And I know why it was asked, because people often, when they start technical debt, they think static analysis. Technical debt is a real thing. It's absolutely important. It's huge. It's critical. We incur that consciously by saying, hey, that's okay, I'll fix it later. Or, hey, that's okay, it can't happen to me. We incur it accidentally. I didn't think about performance. I didn't think about internationalization. I never knew 1 million users would simultaneously use my system. I never knew that, whatever. Unaddressed static analysis violations are certainly part of a technical debt calculation, but they are definitely not the whole thing. Real technical debt isn't trivial to measure, and static analysis alone doesn't measure technical debt. Technical debt means, hey, you have a wrong requirement, you have a misunderstood requirement. When it said make it fast and you said it is fast, you didn't realize that fast meant 1 million simultaneous users within a second. Maybe you used the wrong frameworks. They're not scalable. They're not portable. They're not localizable, whatever it is. Maybe it's the wrong model, the wrong algorithm. So it's going to be slow, and it's always going to be slow. And you're going to be fighting it over and over. Maybe you forgot your security controls. Static analysis won't find that. If you look at audits for security and safety, you'll see that there are many, many, many things that are part of your debt, like untested code is part of your debt. So it's just important to realize that static analysis is absolutely part of your debt, but anyone claiming that they're going to use a static analysis tool and measure your technical debt is selling you snake oil. And some of those companies you can detect because they'll tell you, oh, well, we measured 10,000 hours of technical debt in your project using static analysis, and we can fix them all in one day. Well, static analysis that you can fix in a day is 1 day of technical debt, right? Like, I mean, the cost of the debt is how much time it takes to deal with it, right? Not not how much time it might take to deal with it if you did it wrong. So those are just, when you see claims like that, you know you're dealing with something that's problematic. Make sure that technical debt remains a metaphor, and its big value is, when did I screw up? When did I make wrong choices? And with that in mind, let's talk about risk. Risk is really important because it helps us manage priority and helps us control noise. Again, I have this little flag. I should have put two of this little guy in the top right, because this is about security and this is about noise. On the right here, I have an example of a coding standard. This is the CERT example, and it's really cool because instead of just giving you static analysis rules and checkers that implement those rules, I actually have a matrix, a rubric that I can use that helps me understand each particular item in the standard. How severe is it? Meaning how serious are the consequences? And how likely is it to happen? And what's the cost of dealing with it? And so I'm looking for that intersection. I want things that are very likely to happen, have a high impact, and are cheap to fix. And I'm going to start there. And that's the red part of this target. So look for tools that actually implement these kinds of things, because the people at CERT have done massive amounts of research. If you want to see that, there's some webinars on it, and ask, and we'll send you a link about it. OWASP has done something similar. I showed this earlier. This is the OWASP risk matrix. It's interesting because obviously things that are exploitable or things that have a high impact I want to fix. If I'm still getting too many issues, I might want the intersection. And so make sure that your tool lets you filter based on multiple criteria and get there. Our tool obviously does that because it's super cool. One other thing is there's this new movement. There's a international standard called ISO 27010 or 27010, and it's about software product quality. The idea is that static analysis tools originally were labeled based on the problem they found. And so we see checkers labeled things like this is an overflow or an array out of bounds or tainted data or whatever. But as an end user, and especially as a manager or a senior manager, I don't understand what is the risk of that. And so 27010 is an attempt to figure out what is the impact of these things. Is it a security issue, an operability issue, a portability issue, et cetera? And so we see movement in the industry to move toward this. And in fact, like CWE is moving toward this. These blue buckets are the ones that CWE currently uses. And so now I know, oh, this is a performance issue. This is reliability. This is security. And so for me, if it's an internal thing, but it needs to be fast, I'm going to call everything in the performance bucket high, and everything in the security will be a medium or a low. Later, when we decide to go live, security might become critical for me, but I can choose. So look for tools that are adopting industry standards like this, because they're going to really help you. Now let's talk about some intangibles, right? Let's make sure that we're measuring the other things, not just features, because again, all tools look the same. Most organizations, more and more of them are adopting formal policies around static, like you must do this. A lot of times people are doing a bake-off to choose the tool, and a bake-off isn't really that useful. You've seen here some of the features that I'm looking for. What I'm not looking for is just how many things did it find. When you start, I'm going to go through these really, really fast, and I apologize, we're getting short on time, but we do have a white paper we'll be sending to you to explain it in detail, and feel free to ask. We'll send you something afterward. Get recommendations from people who are doing static analysis in your business and who've done it, and find out, make sure, even if it's highly recommended, make sure it's going to work, your code, your process, your culture, that even if someone really, really liked it, but it doesn't have PCI and you're trying to use it for PCI, it might not be a great tool. So keep in mind the big picture on what you're going to do. Look at vendors. Is this a vendor that has a coherent strategy for enterprise? Do they support shared configuration? Do they support risk models? Do they have high-end analytics and reporting? Are they taking into account modern practices like machine learning? Are other people using the tool? So it's important to look at vendors. And with that, I wanted to talk about open source because it's kind of a vendor choice. And again, this is one of the questions you had. you need to look at, is support available and do I need it? Because if you don't need support, or if someone is there supporting that tool, like Red Hat supports Linux, then you can get support, so it's okay. Look at open source and say, is the project active? If I see that no one has made any real changes to a static analysis tool in the last 2 years, I'm afraid the tool isn't going to be up to date. Is it good enough to solve the problems I need it to? And if I'm working with the standard, how much is covered by the tool? Will it scale? It's really important because these are the places where open source falls down. Typically, open source tools are very good in a narrow scope. A person who created the tool had a specific problem. They wrote the tool, they made it solve the problem. Someone else had a second problem, they added to it. But if I look at CWE Top 25, there's 25 different issues that are probably represented by about 100 checkers, and that's a monstrous effort. And the truth is that current studies are showing that there are no open source tools that have full support for any of the major standards. So if you're just trying to make your code better, open source might be a great start for you. If you have to comply with the standard, OWASP, PCI, FDA, Sarbanes-Oxley, HIPAA, et cetera, then probably open source tool just isn't going to be enough for you. Pilot the best ones. You do want to try it in the real world on some real code with people who are going to actually be doing it. It needs to be real code, not static legacy code, because you need to look at an honest answer of, would I fix this? Would I not fix this? Is this important? Am I glad it found it? And then again, just a reminder, look at those workflow issues. Does it work in my IDE? Can I use it in batch mode? How do violations get reported? Can I put it into a workflow? Can I put it into a pipeline? Can I use it as a gate to do code promotion? Can I assign things to the right people? Can I handle my legacy code? Can I set severities? Can I get suppressions done the right way? All of those things, super critical. Scalability. Scalability isn't just, will it work on bigger code and more projects, which is important, but also, will it work for multiple teams, multiple code bases, multiple tiered rule sets? Do I have the API needs to extend it? Does it cover the languages that matter? And how does it integrate with my other activities that are also developer activities? Unit test, code review. For example, you should be doing static analysis on your unit test code. And we actually have, for example, checkers for that, because there's things you should and shouldn't do. Like a unit test without an assertion really is a bad unit test. So speed of analysis is one thing, but it's not really the most critical. The two most important questions that you want to answer are, will our engineers really adopt this and use it? Can we make it work on real code and get it to a zero noise level through configuration, proper suppressions, proper rule selection, et cetera? Is it practical? And will it work for us long term, not just today? Because if you pick a tool that you know you're not going to keep using, you're incurring technical debt. So just, important stuff. Short list, right? Configurable, optimizable, centralized control, support what you need, reporting, full range of checkers, meaning not just flow analysis. A tool that only does flow analysis means that you need one or two other tools to really cover a standard. Make sure that full range of standards, you don't need a tool to do every standard. You need it to do every standard that's important to you or is going to be important to you. And that when a tool says it does a standard, that you can actually tell what it does and that it's actually doing the whole standard. So again, there's this list. We're going to mail this out so you can have it. Just as a quick plug, Parasoft static analysis tools do all of these things. We built our static analysis on top of our compliance framework recently. It used to be that we just had these things and we did them, but we now have this mapless implementation so that you can report like the standard is. Like I said, we have these risk models implemented. On the lower right, you see all these widgets in our UI so that I can take into account exploitability, technical impact, severity, discoverability, et cetera, are all there. We can fully integrate with the IDE. So really cool. With that, let's take, if we have some questions. I think we have a minute or two. It looked like.
Yeah. Hi, Arthur, are you there?
Yeah.
Okay, great. So we have a couple of questions that have come in. One of them is, We are using Sonar Cube, and it's great to start with, but I don't know where to go next. Can you provide some suggestions?
So yeah, it depends on why it's not working for you, or why it's not enough. So if you're trying to cover a standard, you can look at some other tools and see if the two tools together will do a standard. If it's got too many false positives or noise or has a more fundamental issue, then you need to look at other commercial tools. If it won't work in a language you need, then there's very different answers depending on language. What's available in Java versus C versus PHP, et cetera, are all very, very different.
Okay, and the last question is, I outsource the development of my application. What is the best way to use static analysis to ensure the quality of the deliverable?
Oh man, super great question. And I totally missed putting that in here. Outsourcing, yeah. If it was me, I would first decide what is my static analysis tool and policy. So I would say, hey, we're going to do, we've got to do FDA compliance. So we're going to run this particular tool for FDA with this configuration. Put it in the contract and say, hey, severity 1 have to be fixed. Severity 2 can be fixed with a suppression. Severity 3 can just be suppressed, and severity 4 have to be whatever your policy is, into the contract. The reason that I say a specific tool and configuration is that the current state of the art, for lots and lots of reasons, means that you can't really say that I'm going to use tool A and they're going to use tool B and I'm going to require it. The tools are very different. The technologies are very different. The standards have a lot of ambiguity. And so currently, if you want to work with an outsourcer, you should tell them what tool, what config you're going to use. You should make them run it, and you should make it part of your acceptance testing. Set the policy, and you can run it as just a gate. And you can say 0 SEV1s and SEV2s with suppression and SEV3s, I don't care. And you can measure it and you can hold them accountable. So that's the best way. But yeah, great question.
Great, thank you, Arthur. I think those are all the questions that have come in today. I'd like to thank everyone that was able to attend today's webinar live. As Arthur mentioned, these slides will be available for everyone that registered. Along with that, the recorded link to this webinar. Thank you very much, Arthur. Do you have any final thoughts you'd like to say to everyone?
Yeah, so just one thing, as you look at the list in the future, and we're going to send you the white paper, look through it in detail and see, what it is. If you don't understand, please, feel free to send us a message, or if there's something you thought we missed that we haven't taken into account, love to hear about it. Thanks, everybody.
Thank you, everyone, very much. This concludes today's webinar. We hope to see you at our future webinars. And if you have any additional questions, please email us at info@parasoft.com. Thank you so much, everyone. Have a good day.